everyone. Today we will be beginning to do algebra, which will consist of sets 8 to 10. So if you are not already aware, algebra is a branch of mathematics which involves unknown numbers, and the unknown numbers are represented through pronumerals, which are essentially just letters that, as it states, represent unknown numbers. Now, algebra is an incredibly important area of maths. It will come up a lot, especially in the later years of, like maths, but even things like science. And so it's incredibly important that you understand the basics of algebra. Luckily, algebra is not so complicated in a sense where it works the exact same way that arithmetic does. So as you can see in these examples, it says, average of 10 and 6 is just written as 10 plus 6 over 2. And if it asks the average of x and y, it's just written as x plus y over 2. And you see it also works like that in multiplication. It just becomes, your pronumeral times whatever the number's given to you, and you just place those together and it's just written like so, with the number in front and the pronumeral after it. And one thing to note is that this number in the front, or any whole number, not whole number, but any number in the front of a pronumeral, is referred to as the coefficient. And this is important to note once we begin to look at things like how to add and subtract, divide and multiply algebraic numbers. And so, as you can see, it follows the exact same way that all arithmetic does, especially even down here, the next two odd numbers, 11 plus 2, 11 plus 4 after y plus 2, y plus 4. So to grasp a pronumeral is not that difficult. It works the same way that regular numbers do. Okay, so when it comes to adding and subtracting in algebra, you have two categories of terms. So you have what is called like terms, and you have what is called unlike terms. And like terms refers to numbers that are identical except for the leading number or the coefficient in the front. So as you can see below, there's 3 examples given, and if you look at the first 3 numbers, you'll notice that all of them have a as their pronumeral. So that would be the pronumeral that makes all of these like terms. And your second example has AB, AB, and AB. So again, AB is what makes all of these numbers like terms. Similarly, you have down here x squared, and x squared. So what makes these like terms is x squared. Now, it's incredibly important to ensure that you're paying attention to any powers as well, because you'll see in the unlike terms down here, x squared, x, and no pronumeral, these are all different. So the x squared and the x, they're distinguishable, they're not the same, and they're not like terms. And even if it was, let's say, x squared and x cubed, those are not like terms. And you can also see here that A, B, and AB distinguish from one another because AB is essentially the simplified form of writing A times B. And we know that the pronumerals are numbers, so obviously it's not going to be the same as A or B, regardless of whether the coefficient is the same or different. And so once you learn how to, distinguish these two categories, you'll note that in algebra, you can only add or subtract like terms. So that involves, a method of grouping that is shown below. So we'll go through it together. So it's asking you to simplify this equation. And when it says simplify and it gives you like an equation that involves like pronumerals and numbers, it's basically asking you to group together all the like terms and, like just do how you would do regular addition or subtraction, just keeping in mind that it's only with the like terms. So we have at the start 8x squared, and like keep in mind that this is a positive because there's no negative sign at the front of it, so it's a positive 8x squared. So that's going to be represented by the circle. And what else has an x squared? Plus 2x squared. So that's also a circle, and it's drawn better here. And then you'll notice that that's it. So then we go into the next number and we notice that the pronumeral is x. So we look for any other numbers that are like terms with negative 3x squared. And there is one here, and it's grouped together as a square. So you have negative 3x, and you also have plus 5x, and then you just have the lonely negative 4 represented by the triangle. And so if we put all those together, that would essentially be plus 8x squared plus 2x squared, which gives you 10x squared. And then you have negative 3x plus 5x, which gives you plus 2 squared. And then you just have the minus 4, the negative 4 at the very end. So we can also look at it through, it's zoomed in a bit. Okay, so let's have a look at example. Okay, let's do this one because it involves a lot more negatives. So again, 6a and negative 2a are going to be like terms, so we can just square bracket those, and that just gives us, we can rewrite it as 6a minus 2a. Make sure you're always paying attention to the sign at the start of the coefficient as well, because that is included when you're separating terms. So that just becomes 6a minus 2a, and then we will group together the b. So just as a circle, first one is negative 3b, and the second one is negative 6b. So that is again minus 3b minus 6b. And that just gives us 4a minus 3b minus 6b is minus 9b. And this one, even if it seems a little complicated, just pay attention how this one, 8ab and negative 10ab, those are like terms. Plus 5b and minus 2b are like terms, and that just gives you that. And even in the final example, which includes x squared, again, 5x squared is one like term, and that's just pulled in with x squared, or positive plus x squared, so like so. So yeah, it's not all too complicated. It just requires careful attention to, well, when you want to add or subtract like terms, always make sure you first pay attention to, what the like terms are, and always be wary of the sign that is in front of the like term, because that gets grouped in with the like term, as it mentions here. Okay, So now to do with multiplying and dividing per numerals. So as you can see, as I mentioned like way earlier, if two per numerals are grouped together, you're essentially simplifying what is p times x. And that goes with the same as, like, for example, a b refers to a times b. And when it's division, typically we'd like to write it in the fraction form. So, a divided by, b is written as a over b. Okay, so there are a couple of rules which I'll try to go through methodically so everybody understands it. So when it comes to multiplying and dividing per numerals, when you multiply per numerals, you typically do end up like being able to just join all of the per numerals. So it's not like adding or subtracting where you need to keep the like terms separate. Oftentimes they do interact. So, for example, in like example 2, you have a times b times 5 times another a. So that gives you, that'll give you 5 and a squared because there's 2 a's here, and then a b at the very end. And always keep in mind that the number or the coefficient is always at the front, regardless of, how the numbers appear, like in what order in the equation. It doesn't matter because our final answer must always include the coefficient at the front. And it mentions here that a times a is a squared, but if there was, let's say, another a in the equation, then it become a cubed. So hopefully that makes sense. And you can see here that again the numbers are written in fraction form. The division is written in fraction form, and then you just simplify it. So negative 12m divided by 6, you can write it in that form, and you can just cancel out the coefficients because that's available to us through division, and that just gives you negative 2m. And again, you can also cancel out pronumerals in the form of a fraction. So you notice how you can divide these by 2, which will give you 3 and 4, and you can cancel out the a's as well. And it says here divide the top and bottom by 2a, and then if you simplify that, or if you write it out, it gives you 3b over 4. And again, with, even if there's like a squared, like if it's m squared and at the bottom is just an m, that can be cancelled out to write m, and the per numeral doesn't exist anymore on the bottom. And so that just, essentially gives you 3m. And we'll go through 6 and 7. So in 6, you can notice that they're all negative. So negative 3a times negative 2a gives us 6a squared because, keep in mind that there's 2 a's, which becomes a squared. And then you're multiplying it with another negative 4a. So you're bringing another a into the number, which will give you negative 24, because be aware of the sign at the front, negative 24a cubed. And so for 7, we'll just go through it methodically. So first it gives us 4ab all in a bracket, and all of it is squared. And that's essentially asking us to square everything within the bracket. So if you ever get, if you ever get a bracketed number and then there's a power symbol, always make sure you apply it to every single number, including the coefficient and the pronumeral. So 4 squared gives us 16, a squared gives us a squared, and b squared gives us b squared over 8ab squared. Okay, now keep in mind that this does not mean it's this does not mean it's 8a squared b squared, it's just b squared. And so if we simplify it, we can simplify the b squared, we can simplify out an a, or cancel out an a, and just have an a at the top, and then we can cancel that out, divide those 2 by 8, so you get 1 and then 2. So your remaining answer is 2a. And as it says here, we're always going to be looking for the highest common factor amongst the numerator and the denominator. And so algebraic fractions, again, they work in the same way that ordinary fractions do. So they've written out a really nice and concise step-by-step process on how to do that. So if you notice that the denominator is not the same, just like how you would do with an ordinary fraction, you must first make sure that you find a common denominator, and then you just perform, the addition and subtraction on the numerators, and where you can, simplify it down. So as you can see, all of these up here are like terms, so we are able to add the numerators together. And again, you notice that all of these have, the same denominator. And so, like x plus 2x all over 6 gives us 3x, but just be wary that those two can be simplified. If you divide both by 3, you just get a 1, and then you just get a 2, and we don't need to write 1x, we can just write x, because it's already 1 times x, over 2. And so it cancels down. Okay, and even for example 4, it just becomes like this, it was what we did earlier with grouping like terms. So these two are a like term, and these two are like terms. So we can just rewrite it as 5x plus 2x plus 4 minus 1 all over 8, and that gives us 7x plus 3 over 8. So yep, just keep in mind, again, we're still applying the like terms and excluding unlike terms. Okay, and now they give us some examples on how to add and subtract fractions that add and subtract fractions that don't have a common denominator, and it is quite simple. We'll try with, I'll see which example is. Okay, so let's try with this example. So the lowest common denominator between 3 and 5 is 15. So we'll have to multiply this by 5 and this by 3. So I'll just write it on the side here. 3 times 5 minus 2a 5 times 3. But again, whatever we do to the denominator, we have to do to the numerator. So that becomes times 5, and that becomes times 3. And you're just timesing, you're just changing the coefficient. So 4 times 5 is 20a over 15 minus 2 times 3 is 6a over 15. And if you just put it all together, it just becomes 20a minus 6a. Be aware of the symbol or the sign. And that just gives you, so 20a minus 6a is 14a over 15, like our answer there. And yeah, and also be aware that you still have to cancel down, as it mentions in this example. All right, let's do example 4. So when you're given something like, let's say, x plus 1 or x plus 2, or just like essentially like anything, and you want to find the lowest common denominator, if you're going to multiply the denominator by a certain number, you need to multiply the entirety of the numerator with whatever number. So if I'm doing times 4 in order to get the lowest common denominator, then I'm going to have to multiply it, the entirety of the numerator, which is x plus 1, by 2. And that's written in bracket form. And how that works is it shows it right here. So if you pay attention to that, you'll get, so you'll be writing it out as 2 bracket x plus 1 over 8. And how you expand brackets, if you need a refresher, is you just multiply like so. So that is times 2, and so that just becomes 2x plus 2. And also be aware of any numbers, like for example, if this was not a plus, it was a minus, then this would be a minus 2, not a plus 2. And it, if you expand the brackets, that's what you get. And you notice how that's a like term and that's a like term because they both have the pronumeral x, and 2x minus 2x is 0, so you're just left with the 2 here, the plus 2 here, which gives you 2 over 8, and that can be simplified down to 1/4. Okay, and lastly, we just have 2 more steps to go. So multiplying fractions and multiplying and dividing fractions. So I'll quickly start off with multiplying algebraic fractions. As you can see, it works exactly how ordinary fractions work. You multiply out the numerators, multiply out the denominators, and simplify. So you can see here that m times 2 is just written as 2m, and 3 times x is just written out as 3x. And yeah, if you notice in this example, if there's, if they become like terms or the pronumerals the exact same, you can just cancel it out. Again, you can also cancel out the coefficients and the numbers down here. And this is a bit more advanced, but it just works the exact same way. It becomes 3a over 6 times 2a. You're just multiplying the coefficient with the 6, which becomes 12a. And that can be simplified down to 1/4 because the a's also cancel each other out. And okay, we're a little short for time, so finally we'll do the most complex example. So 3x squared y times 8a3. So if I just put these two together, that's what I'm doing right now. 2a times 5 xy. And so 3 times 8 is 24. Then you have the x squared, and then the singular y, and then the a cubed over 2 times 5 is 10, a x y. And you can just order the numerals in the order in which they first appear. And if we want to simplify this down, we have 24. You can simplify that, or you can divide both by 2, which gives you 5, and then that gives you a 12. And you notice how there's an x, so the x can be cancelled out, leaving us with just an x at the top. So that becomes 12x, currently over just 5 because the x got cancelled out. You can cancel out both y's, so there's no remaining y's, and then you can cancel out the a, which gives us leaves the top with an a squared instead of an a cubed, and just leaves us with nothing at the bottom except for the 5. And that's how you get the answer there. Okay, lastly, dividing fractions works the exact same way as dividing regular fractions do. As we established earlier, algebra works the exact same way that arithmetic does. So the steps that were probably taught to you was to invert the second fraction and multiply. So you can see here the n over 6 is inverted into 6 over n, and you just proceed with how we did multiplication as above. So this is probably the most challenging example. Then if that's the case, first we'll have to write out the first fraction as normal, and then change the sign to a times, and then we invert that, so that becomes a 10y cubed over 3x, and then we can just multiply together. So 6 times 10 is 60, x squared remains the same, there's no x's here, and y cubed is also added but remains the same because there's no y's there, over 5y times 3x, so 5 times 3 is 15, and we'll just write it as xy to match the one at the top. And then we can proceed to simplify. So we can simplify, we can divide the coefficients by 15, which will give us 1 here and a 4 there. And we can cancel out the x's, it leaves us with an x up here, nothing down here, and cancel out the y's, which leaves us with y squared, and nothing down here. So that can just be written as 4x y squared, and we don't really need the over 1 because that's implied, and so that is your final answer. Alright, so that is just covering like terms and adding, multiplying, subtracting and dividing, both just regular algebraic numerals as well as fractions. Today we will be reviewing expanding and factorizing brackets that involve algebraic terms. So as you can see, we will first begin off with doing expansion, and essentially what expansion asks you to do is to remove brackets, and by multiplying the term outside of the brackets by each of the terms inside the bracket. So that is your general rule, and that written out essentially looks like this. So as you can see, you're just multiplying a with b and a with c, and coming to the expanded form right there. So let's review a few of the examples. Let's look at example 1, 3, and 5. So as you can see, example 1 is fairly straightforward. It's just asking you to expand 6 bracket a minus 3. And so how you'll do that is you'll multiply a by 6, and you'll also multiply negative 3 by 6. Minus 6 times 3. And 6 times a just gives you 6a. Negative 3 times 6 gives you negative 18, like so. Alright, example 3 involves a negative number outside of the bracket, but it follows the same rule. You want to multiply p by negative 5? Oh, sorry, did I say negative 3? I meant negative 5. Negative 5, and you want to multiply positive 2 by negative 5 as well. Always make sure you pay attention to the symbol at the front of any number. And so that essentially gives you negative 5 times p plus negative 5 times by 2. And so that gives you negative 5p. And when you multiply a positive and a negative, you get a negative, so that becomes minus, and 5 times 2 is 10. Lastly, we have a question or example 5, which doesn't give us any number. However, because it gives us a symbol, what we need to do is we need to assume that there is a 1 at the front. So this is how it should be pictured in your head. And once we do that, it becomes very straightforward once again. Negative 1 times by 2 and negative 1 times by positive 3y. So negative 1 times 2 is negative 2 plus negative 1 times by 3y gives us negative 2 minus 3y, like so. Okay. And yep, as it asks you to note, a minus sign outside of a bracket reverses the sign inside of the bracket. And once again, it asks you to pay close attention to the last 3 examples. So yeah, just be wary that if you have like a coefficient at the beginning of a term inside the bracket, the 3 is going to change that into a negative 6. Alright, and here are a bit more challenging examples. So I think we should go through what would be important to go through. Let's go through example 3, example 5, and example 6. Okay, so let's start off by going through example 3. So first, it's asking you to multiply or expand the brackets, and then it asks you to add the like terms. So just make sure that when they ask you to simplify, they're asking you to expand and then group all the like terms together, which is grouping like terms we covered last week. And so how we do example 3 is it'll be x squared times by 2x and x squared times by negative 5. So when you have x squared times by 2x, because you're multiplying x squared with another x, it then becomes an x cubed, because it will be x times x, and the coefficient stays the same. So you're getting 2x cubed, and x squared times negative 5 gives us 5x squared. And here it's asking us to multiply positive 3x by 4 and multiply negative 5x by positive 3x again. So 3x times 4 is just plus or positive 12x. And when you are multiplying two x's together, you're getting an x squared. And because it's a positive and a negative, you'll be using minus because that makes a negative. And 3 times 5 is 15. And now, it's asking you to group all the like terms together. So 2x cubed has no like terms because nothing else has x cubed in it. However, negative 5x squared is a like term with negative 15x squared because they both have x squared as their pronumeral. And plus 12x is again a term on its own. There's no like terms because there's nothing with just x as the pronumeral. So you're left with 2x cubed. Now negative 5x squared minus 15x squared gives us negative 20x squared plus 12x. Alright, now on to example 5. Fairly straightforward once again. Negative 4 minus 4p times minus 3. Alright, so to expand, it's asking you to times p by 6 and times negative 5 by 6. And it's also asking you, again, be mindful of the sign. This is negative 4 is read as negative 4. So it's asking you to times p by negative 4 and times negative 3 by negative 4. So if I write that out, it becomes 6p, and 6 times negative 5 is minus 30, and negative 4 times p is minus 4p, and negative 4 times negative 3 is positive 12. Always be mindful that of, like the signs at the start. And now we want to add and subtract all the like terms together. So 6p is a like term with negative 4p, and negative 30 is a like term with positive 12. So 6p minus 4p just gives us 2p, and negative 30 plus 12 gives us negative 18, like so. Alright, and now lastly, we can go through example 6. So if I just write it out here, 2x minus 4 minus 3 minus 2x. Alright, so firstly it's asking us to multiply 3x by 2x and multiply negative 4 by 3x. So let's do that first. Negative 3x times by 2x. So because there's x's being multiplied with another x, we will write that as x squared. And 3 times 2 just gives us 6. And 3x times by negative 4 just gives us negative 12x. Alright, now if you look at the second bracket to expand, you notice how there's no number, but as it mentioned above, we need to assume that this is a 1. So this would be a negative 1. So it just becomes negative 1 minus 3 and negative 1 times 3 and negative 1 times by negative 2x. So that just gives us negative 1 times 3 is negative 3 or minus 3, and minus 1 times minus 2x. 2 minuses make a positive, and 1 times 2x is just 2x. Okay, so once again, you're going to want to group all the like terms together and add or subtract them. So 6x squared is a like term on its own because there's no other x squared in the equation. However, negative 12x squared and positive 2x squared are like terms because they both have x, and negative 3 is just by itself as well. So if you want to simplify that, you get first 6x squared, negative 12x plus 2x gives you negative 10x, and minus 3, like so. Okay, so now we are moving on to factorizing. Now, factorizing is basically considered just the opposite of expanding. Whilst expanding asks you to, get rid of the brackets, factorizing asks you to implement brackets. And the rule that you want to follow when you implement brackets is you want to pay attention to the highest common factor, and you want to take it out of the brackets. And what they mean by that is, what you want to do is, let's say in this example, it gives you 6a plus 12. So if I put brackets around that, you want to take the highest common factor from 6a and 12 out of the brackets. And so if you just take one quick glance, you'll know that 6a plus 12, the highest common factor would be 6. So I can just divide by 6 and divide by 6. And what I'm doing is I'm taking the 6. When I divide, I'm taking the 6 out of the brackets. So 6 is now placed outside the brackets. 6a divided by 6 just gives me a. And 12 divided by 6 just gives me positive 2, so that just becomes a plus 2. And if you do a mental check, which is just to multiply what you've factorized, 6 times a is 6a, 6 times 2 is plus 12, and so if you expand, you are left with the original equation, so this is correct. So if you are unsure of anything you factorize, just make sure you do a quick mental check by expanding the brackets of what you factorized and check if it gives you the original expression. If it does, then you got the factorization correct. And yep, so even if you get, and you can notice here that the highest common factor can sometimes be a pronumeral. It doesn't always have to be a number. And you can even expand expressions that have more than 2 terms, like in example 4, because if I'm given 5x squared plus 10x minus 15, and I just put brackets, you'll know that just by glance, 5, 10, 15, those are all multiples of 5. And so your highest common factor would be 5. And you just divide everything by 5 to get, or every term by 5 to get the 5 out of the bracket. And 5x squared divided by 5 just gives you x squared, plus 10x divided by 5 is 2x, and negative 15 divided by 5 is just minus 3. And so that is what you're left with. So it is not too complicated. You just need to make sure you're identifying the highest common factor correctly. Okay, so you also should note that not only can highest common factors be pronumerals, sometimes they can include both a number and a pronumeral. So for example, in question example 1, you can see that the highest common factor is 2 and it's an x. And if we just go through Alright, so these are fairly complex from first glance, but they're not too complicated once you understand what we're doing and how we find highest common factors. So I'll just go through it methodically. So 6x squared plus 8x, and it's asking you to factorize it. So you notice how that both have x in them, and not only that, but their highest common factor would be 2, because you can divide both of the coefficients by 2. And if you do that, you are left with 2x being the highest common factor. So if I just put brackets around this and then I multiply each term by 2x, what I'm getting is 2x outside of the bracket. X squared divided by x just gives me x. And 6 divided by 2 gives me 3. X divided by x, they cancel out. And 8 divided by 2 gives me 4. And that's just a positive 4. Okay, same with this, AB minus 12AC. So you notice that both of the numbers can be divided, or the coefficients, which is the number in front of the letter, can be divided by 4. 8 and negative 12 can both be divided by 4. But not only that, you notice how both of the terms have a in them. So a would be included in the highest common factor. And so if I just bracket this and divide by 4a, what I'm getting is I can cancel out the a. So the 4a is outside of the bracket. I can cancel out the a, and 8 divided by 4 just leaves me with 2, and the b is left over because we cancelled out the a's but not the b's, so we get 2b minus, because this is a negative, can cancel out the a's, and then 12 divided by 4 is 3, and the c is left over because we haven't cancelled that out, which just gives us negative 3c. Alright. We can also look at example 4. And example 4, you notice how they both have an m, but not only that, the power is m squared and m cubed, which means that not only is the highest common factor include an m in it, it can actually include 2 m's or m squared, because m squared is the lowest out of the terms and m cubed is the highest. And so if I just write it and then I put brackets around it, and once again 15 and negative 12, the highest common factor would be 3. So you're left with 3m squared. So if I divide it by 3m squared, how I can write this is 3m squared is outside of the bracket, so I can cancel out the m cubed and the m squared, and it just leaves me with an m at the top. And 15 divided by 3 gives me 3, so I'm left with 3m. Messed up multiplication. It leaves me with a 5. So 15 divided by 3 is 5. And so you're left with a 5m. Okay, and the m squared and the m squared can be cancelled out to just give me, get rid of the pronumerals. And negative 12 divided by 3 gives me negative 4. So I'm just left with negative 4. And that is how you factorize that. And example 5 shows you that you can get rid of, the highest common factor can include a negative sign. And typically, this is the case. You want to do this when the first term has a negative symbol at the start of it. You want to get rid of the negative and put it outside the bracket. And so if I write negative 6m plus 12 into brackets, so right now my highest common factor would be negative 6. And if I divide the two terms by negative 6, so negative 6 is outside the bracket, and then you write a bracket. So negative 6m divided by negative 6, those can be cancelled out to just give me positive m. And because the negative symbols are also cancelled out. And positive 12 divided by negative 6. Now, what do we know, or what do we have to multiply to a negative to give us a positive? We need to multiply it with a negative. So we automatically know that if there's a positive here, then inside the bracket would have to be a negative. And 12 divided by 6 is 2. So we're just left with negative 2. And that it's essentially the same process here. You want to take the highest common factor out and make sure that you're paying attention to the symbol. Okay, so the main reason for factorizing is the ability to cancel out algebraic fractions. So if we factorize a complicated algebraic fraction, we can cancel it down much quicker as opposed to just doing it just out of the whim. So for example, we'll do a more complex. Let's do example 3 and example 4. So we are given 12 over 3a minus 15, and they're asking us to simplify that. So first, we'll need to simplify the bottom, so it'll be 12 over, what is our highest common factor? We can see that there's 3a, so we can divide that by 3, and we can also divide negative 15 by 3. So our highest common factor is 3. So 3 is outside the bracket. 3a divided by 3 just gives us a. Negative 15 divided by 3 gives us negative 5, or minus 5. And then we can just cancel the 3 and the 12. And so effectively, we're just left with 4 over a minus 5. That's the same in this example. X squared plus, negative minus 5x over 3x. So you notice that there's an x squared and there's a negative 5x. Your highest common factor in this instance is just the x. And so what that gives us is x bracket x squared divided by x is just regular x. Negative 5x divided by x is negative 5. And we can just cancel out the x's, the x from the 3x, which just leaves us with x minus 5 over 3. Like so. Okay, you should also be aware that you can multiply, or you can expand two brackets. And so these are referred to as a binomial product, which is an expression that consists of two sets of brackets being multiplied together. So these are what would signal to you that you are dealing with a binomial product. And so how you do this is it gives you, it lays it out in fairly simple steps. I mean, this is an extension, so don't worry too much if you don't understand it right away, but it is good to know because it does come up in advanced maths questions. But yeah, it asks you to multiply the first term of the first bracket by the whole of the second bracket and do the same with the second term of the first bracket. So this is bracket 1, and this is bracket 2. And you notice how they've broken up bracket 1 into 2, broken it up by its terms. So what they've done is they've taken out a as a term and just made it so it multiplied with b plus 7. And then they did the same with the positive 3. They just made it multiply with b plus 7 the entirety of the second bracket. And when you do that, it's much easier to multiply and to simplify, because then we're just doing what we've been doing so far, which is just a times b, which is ab, and a times 7, which is 7a, and plus 3 times b is 3b, plus 3 times plus 7 is plus 21. And that's what you're left with. And you should also be wary to simplify the like terms where possible. And so these are just some more complicated examples. We'll have time to go through, let's go through this one, and let's go through this. Actually, let's go through all three because they do have different like important parts to them. So you notice how it's m minus 6 bracket times by bracket m plus 6 bracket. And so if we just break up bracket 1, what we get is the first term, which is m times m plus 6 minus 6, be aware of the symbol at the front, times by m plus 6 again. And so what we get is m times m is m squared plus 6m, and then we get minus 6 times m is minus 6m, minus 6 times positive 6 is negative 36. And you notice how plus 6m minus 6m, those cancel each other out, so you're just left with m squared minus 36. Okay, if you get a number like, if you get an equation, an expression that's bracket a plus 3 bracket, and then it says squared, you're writing it out like this. So it just means the same bracket multiplied by itself or with itself. And so you write it out like so, and you have bracket number 1, bracket number 2, and if you break it up, the first term is a plus 3, plus 3, that's the second term, a plus 3, and a times a is a squared, plus a times 3 is a 3a, plus 3 times a is 3a, plus 3 times 3 is 9. And if we group the like terms together, which is positive 3a, we get a squared plus 6a plus 9. So you notice how this is 2 of 3 and this is 3 squared. Alright, and lastly, again, because it says squared, we write it out as if we're multiplying the same bracket twice. bracket number 1, bracket number 2. So we can break the bracket number 1 by its term. So that becomes term 1 is, the first term is 2m. And minus 5 is the second term. So it's minus 5. 2m minus 5. And so that gives you 2m times 2m is 4m squared. 2m times negative 5 is minus 10m. And negative 5 times 2m is again negative 10m. Negative 5 times by negative 5 is positive 25. And you get 4m squared. Negative 10m minus negative 10m is negative 20m plus 25. Alright, so that concludes the theory of algebraic expressions, including, so what we covered was grouping like terms, algebraic fractions, adding them, multiplying, dividing, subtracting, and we also covered expanding and factorizing.